Welcome back. We'll be starting a new lecture series from today, and that is about named organic reactions. So let's begin. So the first of these reactions is the Aldol reaction or Aldol condensation. We'll discuss the reaction, the product that is produced, and the reaction mechanisms. So let's see how it works. The basic requirement for aldol reaction to take place is the presence of an aldehyde that is enolizable, or in other words, this aldehyde must have alpha hydrogens. So let's see an example in which we have an aldehyde that is enolizable or it does have these alpha hydrogens and see how it reacts. So here is an aldehyde and we're going to react it with a base that is hydroxide ion. You can see that this aldehyde does have this alpha carbon, which is a CH2 of course, and it does have these two alpha hydrogens, which means that this aldehyde is enolizable. The product that it will give will look like this. So this is the aldol addition product or aldol reaction product of this aldehyde. Let's see the mechanism, how this happens and how the reaction proceeds stepwise. So what happens in the first step is that the base abstracts one of these hydrogens. These hydrogens are acidic in nature because they are close to an electron withdrawing group, that is the carbonyl group in this case. So the base can easily abstract one of these hydrogens, giving the enolate anion. This enolate anion then attacks another molecule of the same aldehyde. In fact, it attacks from the carbon of the enolate on the carbonyl carbon of the second molecule of the same aldehyde. And this is what happens as a result. We get this oxyanion, and this aldehyde is restored. This one is restored, and this becomes the oxyanion, which takes a proton from water to give an alcohol. In fact, an aldol in this case, because we have the OH group in the molecule as well as the aldehyde. So we call it the aldol, and this is the aldol addition product. This aldol addition product may undergo dehydration under the same conditions in the presence of a base if this base abstracts this second acidic proton, which helps in the removal of water to give an alpha beta unsaturated aldehyde as a result. Now this is the condensation product, and we call this reaction as the aldol condensation reaction. So you saw that the basic requirement for aldol reaction to occur is the presence of these alpha hydrogens, which makes these aldehydes enolizable. So if we have an enolizable aldehyde and we treat it with a base, we'll get this aldol addition product, which upon condensation or dehydration gives the aldol condensation product. This type of reaction is also known as self-condensation. But what if we have two different aldehydes? One of them is enolizable and the other is not. So let's see how the reaction will proceed. So if we have benzaldehyde and you react it with another aldehyde similar to the one we saw in the previous example in the presence of a base, what will be the product? You see that one of these aldehydes, that is the benzaldehyde, is not enolizable, while this one does have these alpha hydrogens, so this is enolizable. So this base will enolize only this aldehyde, leaving behind benzaldehyde intact. So what it does is that it abstracts one of the hydrogens from the enolizable aldehyde to give the enolate anion. This enolate then attacks a molecule of benzaldehyde as a result. So when it collapses back, this carbon attacks the electrophilic carbonyl carbon of benzaldehyde, giving this oxyanion. And this aldehyde is restored again. Again, it takes a proton from water to give the aldol product. But this time, the product is not a self-addition product, but it's a cross-aldol product, which can then be dehydrated in the same manner as we saw before by abstraction of this acidic proton in the presence of a base to give this alpha beta unsaturated aldehyde. But this time the product is known as the cross aldol product, and this reaction is known as cross aldol condensation. So aldol condensation can be self condensation or cross condensation depending upon what type of aldehydes you are using. If the aldehyde that you're using does not have any alpha hydrogens at all, then aldol reaction will not take place, but in fact another reaction takes place which we know as the Cannizzaro reaction, which we will discuss later on. Thank you so much for now. See you later.